Hi students, this is Mrs. Kang. So for today's homework help, for module 2-1, Google Form, workbook, worksheet page 7, 1 through 12, and 17 through 18. So I'm going to start by writing right here the homework heading. So I'm going to write the module 2-1. Just for me, I'm gonna write GF for Google Form. You can do that as well. Workbook, worksheet, page 7, 1 through 12, and 17 through 18. And then I'm going to write my name, date, and period. Date would be, let me just quickly check. Ooh, it'll be the September 2nd. Sorry. Today's actually Friday, the week before, period 1. Okay. All right. So if you take a look at the first 6 problems here, it says list the factors of each number. So I'm going to go ahead and do numbers 1 and 3 here. So factors of 5 and factors of 60. So I'm going to write for number 1, 5, and I'm just going to put colon here. And it doesn't take much space, so I'm just going to skip 2 lines, and I'm going to write number 3, and I'm going to write 60 so that I can find factors of 60. And the way I'm going to find this, it says list the factors. So we are going to list all of the factors that when you multiply those 2 factors that go together, it should give you 5, and then another set of factors that would give you 60. So I want to write them in order from least to greatest. So I'm going to use what a lot of elementary teachers call the rainbow method. So like just, you know, the smallest number and then its pair and so on and so forth. But if you look at 5, if you think about it, the only factors are 1 and 5. And so really, that's the answer. Those are the only factors of 5. By the way, when you only have 2 factors, 1 and the number itself, we call this number a prime number. Some other prime numbers are, you know, like 7. 1 and 7 are the only factors. 11, 1 and 11 are the only factors. Okay? Okay. All right. 1 and 60. And then let's try the next digit. 2 and 30. What about 3? 3 and 20. How about 4? Hopefully you know 4 and 15. 5 and 12. Oh no, I'm running out of space. 6 and 10. Okay. You guys, I'm actually going to write this all over again because I just don't like this just running out of space. I thought I gave enough space, but I guess I didn't. So I'm going to just rewrite them. 1 and 60. That should be enough. 2 and 30, because 2 times 30 is 60. 3 and 20. 4 and 15. 5 and 12. 6 and 10. And then 7, no. 8, no. 9, no. 10, we already got it right here. Okay, so those are all the factors of 60. By the way, when you're asked what are the factors of 60, a lot of students say 1 times 60, like that. A lot of students say 2 times 30. You're not giving me what numbers you are multiplying to get 60. When somebody asks what are the factors of 60, you say 1 is a factor of 60. 2, 3, 4. If you want to give pairs, and you say 1 and 60, 2 and 30, because they're asking you what are the factors of 60. Okay, you don't say 6 times 10 are the factors of 60. You say 6 and 10. Okay. All right, let's take a look at the next part. So over here, 7 through 12, it says find the greatest common factor for each pair of numbers. And I'm going to find the greatest common factor of 8 and 12 and 6 and 15 using the ladder method, or we also call them the step diagram method, or the upside down cake method. So I'm gonna go ahead and write number 9, and I'm gonna go ahead and draw the ladder and write 8 and 12. I'm going to skip some space. Let me see if I can enlarge this just a little bit though. Okay, all right. And then I'm going to skip some space, and I'm going to also write down the problem for number 10 right here, just so that I know that I will need to do those 2 problems. Okay. All right, let's start with number 9. So when you are solving for a greatest common factor using this strategy, what you want to do is you want to look for a factor that goes into both 8 and 12. So you're looking for a common factor of 8 and 12. There are a couple of them. There's 2 and there's 4, okay? I'm gonna divide by 2 and see what happens. So 2 goes into 8 4 times, and 2 goes into 12 6 times. Now if you take a look, you can still divide by a common factor. There is a common factor, which is 2. So I'm gonna divide by 2 again. 2 goes into 4 2 times, and 2 goes into 6 3 times. Now if you take a look, 2 and 3, there's no other common factor for 2 and 3 other than 1, and you don't want to do that, so then that's when you're going to stop and circle the numbers that are only on the left side and multiply them. 2 times 2, your greatest common factor equals 4. Now, just on the side, what happens if you divide it by just 4 to begin with? Well, so if you divide it by 4, it goes in twice, and then it goes in 3 times. Notice you're ending with the same numbers on the bottom, and you circle the number on the left, and when there's only one number on the left, that is the greatest common factor. So actually with this ladder method, the greater common factor that you can use, the shorter steps that you're going to take, the less steps you're going to take, okay? All right, so we have another one, number 10, and this time we want to find the greatest common factor of 6 and 15. So I'm looking at 6 and 15, and the only factor I can think of is 3 that goes into both numbers. 3 goes into 6 twice, and 3 goes into 15 5 times. There's no other common factor. That means you need to stop and circle the number on the left, which means your greatest common factor equals 3. Okay, all right. And then we have a couple of word problems. I think between the 2, okay, so I'm just going to, for number 17, be careful because it asks you 2 questions. It says, what is the greatest number of necklaces she can make? Which means you would want to do the upside down cake or the ladder method for 24 and 30. But it also asks you how many beads of each type are on each necklace. So then once you find the upside down, use the ladder method to find the greatest common factor, make sure that you answer that question. And if you refer back to the notes, the video that I made, or the lessons that your teachers, like lesson that I taught you, to figure out how many beads of each type are on each necklace, what you can do is when you look at the upside down, when you're done with the upside down cake method, you can look at the leftover numbers, and that would give you how many beads of each type are on each necklace. Okay, the one that I'm actually going to do is number 18. Okay, it says the marine life store would like to set up fish tanks that contain equal number of angelfish, swordtails, and guppies. What is the greatest number of tanks that can be set up if the store has 12 angelfish, 24 swordtails, and 30 guppies? So you're dealing with three types of fish. However, how you solve it is exactly the same. So I'm still going to use the upside down cake. So I'm gonna write 18. Okay. Remember, there's nothing between 13 and 17. Numbers 13 and 16. You don't solve them. There's after you go over number 12, you jump straight to 17 and 18, and that's all you do. Okay. All right. So I'm going to make the ladder, and I'm going to write 12. I don't know if you can. Gonna write 12, 24, and 30. Okay. Okay. Now it's a little tricky because now I have to think about a factor that not only goes into two numbers, but it has to go into all three of them. But do you notice that all three of these numbers are even numbers? So when you have all even numbers, there is a number that would definitely go into all three of them, which is 2. Okay. I'm looking at the numbers and I can see that also 3 would work. But 4 wouldn't work because 4 goes into 12 and 24, but it does not go into 30. 5 wouldn't work. 6 would work, right? 6 goes into 12. 6 goes into 24 and 30. Okay, so you can really divide by any of those numbers, but let me try dividing by 2. So going in 6 times, 2 times 6 is 12. 2 times 12 is 24. And 2 times 15 is 30. Take a look here. Can you tell what common factor it still has? 3. You can still divide by 3. 3 goes into 6 twice. 3 goes into 12 4 times. And 3 goes into 15 5 times. Now look at the numbers. There is no common factor of 2, 4, and 5, which means you're done. You're going to circle the numbers on the left, and you're going to multiply them. 2 times 3, so your greatest common factor equals 6, which means, but you don't want to just write GCF is 6 because it is a word problem. So word problem needs words in their answers, and we want to write them in complete sentences. So the greatest number of tanks that can be set up is 6. And I want to circle the whole thing. Okay, all right. So that's it for today. I'm going to stop before my child starts talking to me. Okay. Okay.